Section 6.6 is on function operations. You can add, subtract, multiply, and divide functions as you would real numbers or other expressions. You must, however, consider their domains. So for example, for addition, f plus g of x is the same as f of x plus g of x. Just add the two functions. You can subtract two functions. You can multiply two functions. You can also divide two functions, but here's where you need to take a look at the domain. G of x cannot be equal to 0 because we can't have a 0 in the denominator of a fraction. Let's take a look at a couple examples here. Our first example says, let f of x equal 5x cubed plus 1 and g of x equal x squared plus 4, minus 4. So we need to find f plus g of x and f minus g of x. So f plus g of x is just going to be f of x, which is 5x cubed plus 1, plus g of x, which is x squared minus 4. And then just simplify that, which there's very little to do. So 5x cubed plus x squared minus 3. So that's what I get when I add those two functions. And in this case, x can be anything, so the domain is all real numbers. Okay. Now when we subtract f minus g of x, again, it's just f of x minus g of x, but it's a little tricky because we need to make sure that we subtract the entire second function. Okay, so that means this is going to be 5x cubed plus 1 minus x squared plus 4. Subtracting each term is almost like distributing a negative 1. So then putting those in declining order of exponents and combining like terms gives me 5x cubed minus x squared plus 5. And again, x can be any number, so my domain is all real numbers. Second example, let f of x equal x squared plus x minus 6 and g of x equal x minus 2, and we need to find f times g of x and f divided by g of x. So f times g of x is equal to x squared plus x minus 6 times x minus 2. And here I would just use the distributive property. So I'm going to take this x and distribute it to the trinomial first. That'll give me x cubed plus x squared minus 6x. And now I'll distribute this negative 2 to the trinomial. Minus 2x squared minus 2x plus 12. Combining like terms, I get x cubed minus x squared minus 8x plus 12. And again, in this case, x can be any value, so my domain is all real numbers. Now to divide, to do f divided by g of x, it's going to be f divided by g. Now before I do anything, I need to see if my trinomial on top is factorable, and indeed it is. That can be broken down into x plus 3 times x minus 2 over x minus 2, and I can cancel, so my final answer is going to be x plus 3. But even though I canceled out this x minus 2, I still need to take into account that when I did do f divided by g, x cannot equal 2, because if x is 2, then the denominator is 0, so my domain is really all real numbers except x cannot equal 2. A composite function is the result of taking the output of one function and making it the input of another function. Here's a little chart from your textbook. So here we have function f, and the domain of f is the input. So I put that x value into f, okay, and what I get out is my output, or the range of f, Okay, so that output of x now of f now becomes the input of my function g, and then the output of g is what we say this is g of f of x. So in other words, put in your value for f. When you get that output, put that value in as the input of g, and then your answer, your solution, is the result of a composite function. You're composing or putting these two functions together. Here's what the notation looks like, and here's another box from your textbook. So the composition of function g with function f is written as g and a little open circle and an f, and that means g of f of x. We write it like this, g of f of x, or I actually prefer this notation where you can see that f of x is actually inside of the function g. Okay, so the way we do this is we're going to evaluate f of x first and then use that result that we get from f of x as the input for g. Important point here, function composition is not commutative because f of g of x does not always equal g of f of x. Let's take a look at an example here, and there's actually two different ways to do this. I'll show you both methods. So we have if f of x equals x squared plus 1 and g of x equals x minus 2, what is g of f of negative 2? I like to write it like this, g of f of negative 2. Now it looks a little scary because I've got parentheses and square brackets, but notice that the function f is inside function g. So the first way to do that is to find g of f of x. So in other words, I'm going to take this function f and I'm going to put it into g for x. This function here becomes my x in g of x. So g of x says x minus 2, so I'll have x squared plus 1 because I'm putting that in for my x, minus 2, or let me put it underneath, x squared minus 1. And that gives me my function rule for g of f of x. Now if I want to evaluate g of f of negative 2, I'm going to use that function rule and put in negative 2 for x squared for x. So that's going to give me negative 2 squared minus 1 gives me 4 minus 1, or my final answer is 3. So that's one way to do this problem. The other is to say I'm going to go straight to finding g of f of negative 2. So the first thing I'm going to do is I'm going to say I'm going to find g of, and now I'm going to put negative 2 into f for x. So that's going to be negative 2 squared plus 1. Because f of x is x squared plus 1, this is x squared plus 1, where x is negative 2. So I need to evaluate g of 4 plus 1, or g of 5. Now I go back to my function rule for g of x, which is x minus 2. So g of negative 5 is going to be equal to 5 minus 2, which is equal to 3. And you'll notice we got the same solution either way we did it. I kind of prefer the first method because it actually gives me the function rule for g of f of x. So in this section, we took a look at some operations that we can do on functions. We can add, subtract, multiply, and divide. Be sure you keep an eye out for the domain, especially when you're doing division. And we took a look at composed functions, composition of functions, and how to do that.